Last month, I blood tested for the second time in 2025. And note that this is test number 56 since 2015. So with that in mind, what's my biological age? That's what we'll see here. This is using Dr. Morgan Levine's biological age calculator, PhenoAge. And if you have blood test data and you want to calculate your own biological age using this test, there's a downloadable Excel link and a link from my website in the video's description. So when entering these data, I get a biological age of 29.8 years, which is 22 years younger than my chronological. So, but is this just a random result? And I should mention that these days I see a lot of people saying my biological age is X or Y or Z. Is that one test a year? Is one test per year representative of a full year average? How many tests per year do we need? So, with that in mind, note that this is test number 2 in 2025. What about test number 1? So that was exactly 6 weeks earlier than the March 18th test on February 4th. And here we can see that my biological age was in the same ballpark, 31.1 years, which is 20.9 years or around 21 years younger than my chronological. And for those who are familiar with the channel, note that the video that I made for the blood test number 1 in 2025, the biological age number is slightly different. And that's because I'm now using the official corrected PhenoAge algorithm. And I think there's been some confusion online about what's the correct algorithm. We had correspondence with Dr. Morgan Levine. It's now corrected. So I'll leave that information in the pinned comment for more details on that story. But is 2 tests representative of a full year average? Probably not. So how many tests do we need? I don't know what the answer is, but I've been testing a lot over the past few years. And with that in mind, I have 39 tests since 2018 where we can take a look at year-to-year change for this biological age test to see how well or not so well that I'm doing. And that's what we'll see here. So when I first started tracking in 2018 to 2019, I only measured 3 times. Now, I have blood test data going back to 2015 and beyond, but it was only in 2018 when I started including HSCRP, which is required to calculate PhenoAge using this test. So that's when the data starts for PhenoAge because I wasn't tracking HSCRP before 2018. Nonetheless, over those 3 tests over that 2-year period, average PhenoAge was 34.3 years. And then I had the thought, as I mentioned earlier, how many tests do I need to really evaluate year-to-year change? So I started testing more often. 6 times each in 2020 and 2021, so 12 tests total over that 2-year span relative to the 3 tests, 2018 to 2019. And then we can see that my average biological age in each of those 2 years, 2020, 2021, was 33.9 years. So from 2018 to 2021, my average PhenoAge was probably somewhere around 34 years. I then started to test more often, now up to 7 tests per year in 2022, with an average biological age of 32.1 years, which was my best to date, which got then a bit worse, 7 tests in 2023, 32.9 years, and slightly a bit worse in 2024, 33.1 years, but now I went up to 8 tests per year. And that's probably where I'll stay for the near future. It allows my veins to heal. It gives me enough time to analyze the data after each test so I can decide on what interventions to try to move the biomarkers towards youthful and most healthy based on all-cause mortality risk. All right, so what about 2025? Well, after those first 2 tests, average biological age is off to a great start at 30.5 years. So what we can see, starting from 2018, is that I've avoided an age-related biological age increase. And that's important to mention because even if all biomarkers stay the same using this biological age test, PhenoAge increases by 0.9 years per year of chronological age. And what that means is if we start the clock somewhere around 34 in 2020, 34 for PhenoAge in 2020, even if 2018 to 2019 was somewhere around 34, when considering that 0.9 year per year increase, my expected PhenoAge in 2025 should be at least 38, but it's significantly lower than that. So off to a good start. So this is as a whole PhenoAge when looking at all of its biomarkers in a composite. But what's the year-to-year change for its individual biomarkers? And I think it's easy to just focus on the biological age score, but I'm interested in optimizing each of its biomarkers and then also other biomarkers that aren't included in this video that I'll go into in the full lab test report analysis next week. So let's start off with year-to-year change for the RDW, which contributes the most to the prediction of biological age using this test, which is what we'll see here with RDW on the y-axis plotted against chronological age on the x. And for the RDW, I have 55 tests starting from 2015, which is when I started diet tracking, that go through 2025. So an average of around five and a half tests per year. So the first question to ask is, what's optimal for RDW? And the RDW reference range is 11 to 15%, but that doesn't say anything about should it be low, should it be high, should it be midpoint of the range. And when I started on this journey way back when, I aimed for midpoint of the range, just I didn't know any better. So if I only focused on the reference range, note that all of these data, these 55 tests, are in that range. So I may be misguided into thinking that I'm completely fine and resisting aging if I'm only focused on the reference range. So that hasn't answered the question, though, of what's optimal for the RDW. So for those who are interested, I have a new Patreon tier dedicated just to what's optimal for biomarkers, including the RDW. And this isn't the focus on the reference range. It's what's optimal based on how do each of these biomarkers change during aging, what's their association with all-cause mortality risk, and it includes data from 45 published references. So if you're interested in that, check it out. So back to our story, what's optimal? So without showing the actual range, generally lower is better. And that's based on how RDW changes during aging and its association with all-cause mortality risk. So with that in mind, when looking at the correlation for the RDW with my chronological age, we can see that I've been able to significantly reduce it over the past 10 years, as the correlation is negative 0.67, close to a strong correlation. Anything less than 0.7 would be considered a strong correlation. And you can see that that p-value is less than 0.05. So I can say that I've significantly reduced my RDW over this 10-year span, when in contrast, the RDW increases during aging. But this is only part of the story, because now the challenge is keeping it flat. If I'm going to resist age-related change, it isn't enough to just get your data to a quote-unquote optimal range or the lowest risk profile. It's keeping it there indefinitely. Or will I succumb to some age-related increase? And note that even though that slope of that red line isn't too high, we could experience age-related changes and still be in the quote-unquote optimal range or even in the reference range and still exhibit aging because our data is changing. So my goal is to keep the RDW within the lower end of my quote-unquote optimal range indefinitely. So can I do that? Stay tuned for that story in upcoming videos. So a big question could be, how have I resisted an age-related change for the RDW? And one factor may be calorie intake, and that's based on its correlation with the RDW. As I've mentioned, I've been tracking diet since 2015, so each blood test has a corresponding average dietary intake because I'm weighing all of my food, and then I can look at correlations because I have so much data, and then I can use the correlations to try to move biomarkers in the direction that is youthful and associated with lowest risk of death for all causes. So in my case, calorie intake is one of the strongest correlations with RDW. You can see that its correlation coefficient is 0.74, so technically a strong correlation, and that p-value is less than 0.05. Now, I post correlations, not just for calorie intake, but all macros, micros, and foods on the correlations tier on Patreon. So if you're interested in that, check it out. All right, so let's focus on a biomarker that I may not be doing as well, glucose, which is what we'll see here. And this is glucose on the y-axis plotted against age on the x. And for glucose, I have 57 tests that go back to 2015, again, since I started tracking diet. So again, the first question is, what's optimal? So actually showing the story this time, before showing that, let's go through the reference range, which is 65 to 99. This is Quest Diagnostics reference range. If we use that as the threshold, all of my data is within that range. So it's not generally informative. So in terms of what I consider the optimal range, it's 80 to 94, and that's based on all-cause mortality risk in a study that included more than 10 million people. So if we compare against that and look at all of my data, and we can look at this data in a few different ways, and I'm going to go through the different ways that we can look at the data, strengths and weaknesses. If we look at all 57 tests over this 10-year span, my average glucose level is 89.6 milligrams per deciliter, which is in that 80 to 94 range, so technically I'm good. I shouldn't have to worry about glucose. But if we put up that optimal range, 80 to 94, we can see that almost all of my data is within the range. 49 of the 57 tests are within 80 to 94 milligrams per deciliter. but 8 of the tests were above that. Now, if we're thinking about aging, if this was flipped, where 49 of the 57 tests were higher than 94, this would be a problem, right? This would be on the road to significantly increased all-cause mortality risk, and the data is going in the wrong direction. So my data shows that I have room for improvement. Although almost all of the tests are within that range, it can be better because 14% of my tests have been out of the range. So I want to limit that as much as possible. So that's only part of the story because glucose levels increase during aging. And if I look at all of the data, the correlation for glucose against chronological age, even though it's not significant, we can see that the p-value is greater than 0.05, but just outside of statistical significance at 0.07, there is a weak but close to significance correlation for glucose levels with chronological age in my data. So there is some small slope for it increasing in my data. Now, there may be good news to that story, though. So this indicates that it needs work, but there may be good news to that story, though, because my last 2 tests, and again, I'm not trying to cherry pick, but this is what the most recent data shows. My last 2 tests, average glucose 87.5 milligrams per deciliter, whereas for the first 14 tests, which was my best data over this 10-year period, average glucose was 86 milligrams per deciliter. Now, if I'm able to keep glucose around 88 or 87 going forward, that slope will further come down. The correlation will further reduce, and the p-value will weaken even further. So I will basically slow the age-related change for glucose. Now, that's a big if. We'll have to see how that story plays out, but that's the goal. To keep the slopes of the rate of change for each of these and other biomarkers as flat as possible. And if our biomarkers aren't changing for decades, how much are we really aging? Now, this is the first part of the story. There'll be 3 parts. In next week's video, about a week from today, I've got some other videos coming midweek. I'll go through the full blood test report. I don't only focus on phenoage. I'm looking at biomarkers of other organ systems too. I'm looking to unturn almost every stone that I can so that I'm not leaving anything on the table. You know, it's easy to only focus on biological age, but it may have weak spots. So we'll take a deep dive into all of the things I'm measuring rather than only looking at these 9 biomarkers. And then in part 3, we'll take a look at the diet and supplements that correspond to a 22-year younger biological age. If you're interested in more about my attempts to biohack aging, check us out on Patreon, where I offer blood test consults, but also post at least twice a day in other Patreon tiers. We've also got a whole bunch of discount and affiliate links that you can use to test yourself that go to help support the channel, including ultralabtest.com, which is where I get the majority of my blood tests done, the clearly filtered water filter, using it every day. I even gave it to my parents, at-home metabolomics, oral microbiome composition, NAD testing with Ginfinity, epigenetic testing with True Diagnostic, at-home blood testing with Cyfox Health, which includes the DNA methylation test GrimAge, green tea, diet tracking with Chronometer, or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. And I should mention, all of these affiliate links are things I'm actively using or have actively used in the near past. So I wouldn't have anything on my channel that I wasn't a fan of and have used myself and believe in. And we also have merch. So if you're interested in wearing the ConquerAging or Diet Trying brand, as I've got on here, that link and all of the other links will be in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.